This presentation, titled Propensity Scores Teach One Assignment, was prepared and presented by Taylor Galownia, a health informatics graduate student at George Mason University. This presentation was prepared for graduate course HAP 823 on causal analysis. Propensity score matching is a statistical technique used to estimate the effect of an intervention by balancing the covariates between the treated and untreated subjects, thus reducing or eliminating selection bias and removing confounding. This Teach One presentation will walk through the steps to complete question 1 of week 3 assignment. I included the posted question above as a reference. Feel free to pause here to thoroughly read through the question if you have not done so already. The objective of this problem is to identify and remove the confounding related to patient types seen by Dr. Smith in order to evaluate the effectiveness of Dr. Smith on length of stay. This will ultimately allow us to compare Dr. Smith's length of stay to his peer groups based on patients with similar diseases. The CSV file above shows the data that we will work with to complete this problem. In order to compare Dr. Smith's length of stay to peer group based on patients with similar diseases, we will complete 3 distinct steps. First, we will perform logistic regression on all covariates predicting the probability of a patient type utilizing services by Dr. Smith. Second, we will calculate and attach propensity scores to the data frame, and then calculate the weights in order to balance the data and remove the confounding. Lastly, we will run a weighted regression on length of stay on various baseline factors to evaluate the impact of Dr. Smith on length of stay without confounding. For this problem, I will be working in R. The first line of code uploads and stores my CSV file as data. The second line creates the logistic regression model. The dependent variable is cared for by Dr. Smith, and the independent variables are all of the variables to the right of the squiggle line. The variables are binary, and the data source is data. The third line of code is where I produce the regression output, which is shown on the next slide. The output of the logistic regression is shown above. Based on the results, we can see that there are certain patient characteristics that differ between Dr. Smith's patients and his peer group patients. Dr. Smith's patients are significantly less likely to have heart failure and metastatic cancer than his peer groups. Since these dissimilar patient characteristics could affect the impact on length of stay, we will perform propensity score matching to balance the data and make patient groups similar. Our next step is to calculate and attach the propensity scores for the dataset. This step is shown above in R. After we attach the propensity scores, we will calculate the weights in order to balance the data. This step is shown above in R. Lastly, we use the weights generated in the previous step to run a weighted regression of length of stay on various baseline predictors, this time including cared for by Dr. Smith as an independent variable and length of stay as the dependent variable. Shown above are the results of the weighted regression. This estimate on length of stay does not reflect differences in propensity of patient diseases. The differences were statistically controlled, which allows us to see the unconfounded impact of Dr. Smith on length of stay. I will discuss the key findings in more detail on the next slide. Based on the weighted results, we can conclude that Dr. Smith has a statistically significant impact on length of stay. Dr. Smith's patients are more likely to have a shorter length of stay than patients treated by his peer group. None of the other variables have a statistically significant effect on length of stay, whether treated by Dr. Smith or not. This concludes my Teach One presentation on propensity scores. Thank you.